can be broken into two sections, mainly because these two sections do exactly the same things. It's just one is for the in and one is for the out. I'm going to go ahead and let Brandon explain some of this part.
This is where we get our system date and time. For the people that are coming in, it takes a string value and gets the time, strips away the date, gets just the minutes and the seconds from the system clock. And then we do a little bit of conversion on the second side to help to convert it from a base 60 to a base 100. And then we add them back together so that we get a whole time or a whole number. Like if we have 3 minutes here and 30 seconds here, on the output here it'll be 3 minutes or 3.5 minutes. This is our case structure, which drives our array logic. This case structure right here is what actually indexes our array from 0 to 3. And then on the fourth case structure, or fourth setting of the case structure, it resets the value back to 0. Next portion of the code is right here. It takes the array and does a conversion on it and adds them all together so that we get a final average out. This portion right here inside the case structure makes it so that the display out will only display when after all three values are acquired. The in time and the out time, and subtracts it, leaving you with the average wait time for the 3 people in and the 3 people out. This case structure, which does a little bit more math, it takes the 3.5 minutes, rounds it down to the nearest whole number, which would in this case be 3, takes that number, subtracts it from the original, giving us the seconds, which we then convert back to base 60, and then add the two numbers, the 3 minutes and 30 seconds, back together, displaying our final average. Okay, then we take the seconds before they're added together and the minutes before they're added together and convert them into an 8-bit binary number, which is then sent to our serial out case structure. And I'm going to let Dallas take over from here.
Here's the final case structure. This uses all of the former information that's being passed through our system and allows us to transfer it out serially. We have a button right here, boolean button, feeding the case structure. This is our update button, and we're feeding it with the minutes and the seconds. This is going to go into this case structure, and as you can see when I toggle through, this is the inner case structure. It's going to change our ability for it to be on half of the time, so there's a 0 and a 1. And we're going to transfer information in off of the 1 off of the clock cycle here. So when the clock hits a 0, this is what our output will look like, and when the clock is at a 1, it will appear to be the inside of this array out through boolean. So as the inside one is also cycled, you can see it starts out as 0. We're indexing through the array, and this is the part that's performing the serial output.
So some of the challenges that we faced in this project were for the counter, counts the number of times we press the button. It works using 2 shift registers. The first one actually is the counter. The second one is counting how many times you press the button, and it does some a little bit of logic right here through this case structure to limit it so that it only counts 1 every button press. We used this to index the array, which brings up our second biggest problem, was actually indexing the array using the amount of times that we've pressed the button. The way it currently works is we have 3 button presses, and then the 4th state is a reset. It took us a while to figure out that we needed a 4th state as a reset due to a lot of complications. Also, this case structure resets on a -1, because without the -1 there, if we were to reset it at 0, we would actually skip the 0's place on the array. The memory portion of this array right here also posed a pretty big issue. When we first built the program, when we indexed the array from the 0 spot to the next spot down to the next spot, it would forget which numbers were entered in previously. So we had to feed back the loop all the way around it, back into the case structure to feed the number back in.
This portion didn't really propose too many issues. It was just a matter of picking which method to use to send serial out. The method that we chose was to only output our minutes and seconds binary digit on a high and to not send anything out on a low. So as you can see, it's being driven here by this for loop, which cycles through a 16 count, which represents our number that we're being sent. 8 bits being sent on the ones, and then of course you got to include the zeros, so that gives us 16. 16 is being divided in half, so that way we can also make it on for half the time. As you can see from this connecting here, leaves this case structure on half the time while we're indexing through a count of 16 for the inner case structure. Like I said, this didn't propose too many problems, but it was just a matter of picking a method and sticking with it.